calculated score? Negative 2.39. Or 40 if I round it to 2 decimal places. So I go to negative 2.4. And then I go to my 0, that's on this side, which is 0.0082.
Right. Okay.
So 0.0082. That is the p-value for the calculated test statistic.
Which you rounded, so that's 2.00. 40.
Well, negative 2.3, negative 2.40, because if I'm using the table, I only have 1 decimal place, 2 decimal places. So if I use the XL, what am I going to start typing in? Norm dot S. Whoops. And its distribution, and I type in the Z-score. The Z-score is the calculated test statistic. And I put in true. And see, it gives me 0.008281. Which means if I round it to 4 decimal places, they're not going to be quite the same.
Okay, I'm following on that.
So now I gotta go back. Before I can make, now I gotta decide. Am I gonna reject or not? So what am I gonna do to reject the null hypothesis?
Your CTS has to be greater than the t-table.
I have to find out, I gotta look at my table. So what's my, so I'm gonna draw my table. And I'm gonna do this every time. Am I left tail, right tailed, or two tailed?
It's one side, but
I want it
it's,
to be
left.
Negative, so it's going to be left. So I'm going to want this value. What goes here?
The alpha.
The alpha,
Which is 0.05.
which is 0.05.
Yeah, 0.05.
Okay. So my alpha is 0.05. So I sort of, and now I have a calculated test. I got a calculated value of negative 2 point something, right?
Mm-hmm.
Calculated test statistic was negative 2 point. Negative 2.39?
Or 40. Yeah.
Okay, 2.40.
And the alpha is negative 1.645.
It's got a p-value that's related to this of what?
0082 or something?
0.0082. Now, that means I've got a table value here where 5% is to the left and 95% is to the right. Do we know what that table value is?
Yeah, the negative 1.645.
Negative 1.645. We looked that up so often. That's why I said we should get to the point where we can just have that one particularly memorized. So this is negative 1.645.
Mm-hmm.
Now, I can look at this. I know my p-value is much smaller than this. Negative 2.4 is way out here, also in the tail. So I know no matter what, when I'm looking at this, my value out here is negative 2.4, which is in the tail. So what does that mean?
it means that we would accept, we would reject the null hypothesis.
Okay? So
Because
there is
sufficient statistics.
sufficient statistical evidence to reject the null hypothesis.
We would always have to put this?
I always recommend that you write that sentence out. If you're doing this and I ask you to do it on a test, I'm going to ask you what your decision is. And you have to justify your decision.
Okay. So we just basically have to understand that we can either go off of the p-values or we can go off of the CTS versus the
Table value.
The table. That's a lot more simpler now.
Yeah. I have to compare two
Yeah.
things.
That was,
But basically what I want to know is, am I in the tail or not?
right.
The smaller my p-value, that means the farther out I am. And if my p-value is less than my alpha,
Right.
then my test statistic is going to be bigger than my table value, and I'm going to reject the null hypothesis.
Okay. Okay, so CTS equals.
But you gotta walk through these processes. And I understand it gets, but you gotta think about what the question is. Because what you're doing is you're looking at sample data to make a decision based on evidence. You're not just gonna look at it and say, ooh, that number seems small. This number, in this case, this number is small. 4,600 is smaller than 50,000. We would not, if I was doing this, I would say, if I was an attorney general for a state, I would say, your tires do not get that, you need to lower your claim. So there's one of two things, they can either try to make the tires better, or they can lower their claim and say, our tires get 45,000 miles or more.
So Attorney General is walking for the
Attorney General, that's, yes, they use this in the court of laws to produce evidence. So that's basically what they're sort of looking at. Statistical evidence.
They do it or they look at somebody else to do it?
Well, they look at lots of different things. This is where they talked about tobacco companies. For years, medical professionals went out and did studies, and they got samples. They created their test, and they had test type, they had null hypothesis, an alternative hypothesis. They collected data, and they would make one decision. Tobacco companies were doing tests, and they were conducting tests, and they would collect data, and depending on how they look at data and how they sort of do it, and what would happen is, sometimes the test would come up and they would reject it. Remember what we sat there and said when we were doing a confidence interval, if we were 95%? So basically what the tobacco companies would do is they would look at the studies that supported their claim and would ignore the ones that didn't. And then the health professionals looked at the ones that supported their claims and ignored the ones that didn't, and they were arguing it back and forth. It's the same argument that they have going on now somewhat with climate change. Is they look at studies, are the differences. Now, the aspect behind it is, they say that the temperature has gone up. And that it's warmer now than it was 50 years ago, so they claim.
Could you finish this one though, because I couldn't figure out, I forgot how to do that last one on I, where it says, okay, 95%. Okay, so what is the mean? I tried putting 50,000 because I was thinking the mean is 50,000, but are they asking for the?
No, when we build a confidence interval, remember we take the sample mean plus or minus.
That's where I lost.
So see, this is going to be the 46,500.
46,500.
On mine, I don't know if your sample was the same size.
Example mean.
The
Oh.
sample mean.
Oh.
And this is where we are going to take the sample mean plus or minus the error bound margin.
Oh, all
And the error
right.
bound margin is equal to the alpha, or the z,
Okay.
the z,
Okay, so that's what I did try to do. That was it. That's what I was trying to do. Okay.
and
so-
they have some alpha divided by 2 times
That's what I got lost
the
on.
standard error.
Okay, so
So
am I still doing the z alpha divided by 2?
whenever we're dealing with confidence intervals, because remember, confidence interval says I want to be right or left, right? So confidence interval always divides alpha by 2.
Oh.
Because I want half of my error on the bottom and half of my error on the top.
Okay. And then I divide that by the standard error, which is the 1414.21.
Right.
No, it gave me something wrong. I did something wrong.
So, what do I do? Why do I keep doing with my glasses?
Yeah, why is that not
Okay.
working?
So now, this says a 95% confidence interval. So that means, what is my z that I'm going to need?
The z?
Z for alpha divided by 2, which in this case is 0.05 divided by 2, which is z 0.025, which means if I look that up in the table, 0.025,
Oh, that's what I didn't
right
get.
here, which is 1.96.
Okay.
So this is 1.96. So that's my alpha, that's my table value. See, this is sort of the same thing, but building the confidence interval is not the same as doing hypothesis testing, because confidence interval, I always split my alpha in both tails.
Okay.
Hypothesis testing, if it's a one-tail test, I put all my alpha in one. Now, here's the aspect behind it. Some people will say always use a two-tail test, because then you use a smaller alpha and you make a more informed decision. So some people would say, no matter what, divide your alpha by 2. Don't worry about a one-tail test. They always do two-tail tests because it will be more stringent.
Okay, 0.025.
So in this case,
So when it's asking for the z alpha divided by 2, they're actually asking for the score, not the 0.25.
they're looking for the table value,
the table value. And what did you put? For the
1.96.
0.96. Not a negative, just a 1.
Because I'm going to add it and subtract it, it doesn't matter whether I use positive or negative. So I always just use the absolute value.
Okay, that's where I am.
So my error bound margin is going to be 1.96 times my standard error.
Times the standard error. Divide.
And then my lower bound and my upper bound. So my lower bound will be my mean minus my error bound margin.
Oh wait, no, I'm not.
And my upper bound will be my mean plus error bound margin. And you can see, this comes up and it says, I am 95% confident that the mean of the population is between 43,637 and 49,365. See, so my confidence interval is below. That's why we're rejecting the null hypothesis. Because it doesn't capture the mean of the
Oh,
population.
this is so irritating. Okay, so that minus that. What in the world? And then it's this upper. Let me see if it comes out right.
There.
Equals that plus that. Okay.
And again, this is, part of your answers is don't overly freak out if your answers are slightly off. Because you saw, depending on whether I used Excel or the table, I got slightly different p-values. I got, so you can sort of see, I'm all, depending on how I round, can vary my answers slightly.
I got it! Yay! Got it. This is why we need the practice test.
Let's see, 44. No. Oh, yeah, wait, okay, yes. Population standard deviation divided by square root of n. That should be good. Okay. So this is your z value, 1.96 times that. And this is your mean.
Having fun, Jonathan? Which one are you on?
I'm done for the day.
Now, I'm finding that this has a bunch of decimal places, and your
Yeah.
answers don't.
You got,
Just
video of them
not
not
to put it.
Not yet, but I
I'll put it
think
as a
now that I'm
number.
starting to get it, I will try to make,
I'm gonna spend a lot of time on this tomorrow.
yeah,
There's
yeah.
one.
We'll see if I'm really getting it, but I think I finally had an epiphany. So,
If I get problems, I text you.
yeah. But if
Yeah, I
I,
kinda get it, it's just slow.
now if I don't get it by tomorrow, I'm gonna come see him too. Mm,
Cause this one's gotta be completed by Thursday.
Thursday?
Oh, on my website, that's what it says.
Okay.
I got not much of it done.
Yeah, I guess it's trying to figure out like what I'm needing in all of these things. This is where I was guessing a lot of stuff, and but I'm putting it in this. So I'm actually gonna send this out, and this is gonna have all the notes. I hope you guys can understand this, but read these notes, all the notes that I put in, because, and then if you have questions on the notes, maybe that'll clear up some things. But at least it'll have, you know, why I put. But I can't help with these, you know, I can put what it is, but, you know, some of them I was just like, what? You know, it's just the opposite of what the other one was, so. Anyway, but this part should really help now that I understand the calculated test statistic, and then that way you guys can click on that and look at the formula and stuff, yeah.
Cool.
So, trying to write down the formula.
Yeah, trying to organize all the different
When you see like
formulas
that,
for what you're looking for
I'm
is the
putting,
challenge.
you could understand that, right?
Yeah.
Okay. Yep. That's what we do, you know, at least we got notes in there that we can all look at, and then, you know, everything. You know, I'm trying to put the notes that he's talking about, and then we'll have the videos.
Cool.
Yeah, and then I'll try to make a video to explain it. Especially if, you know, especially if you're like looking at this and you're like, I still don't get it. That would be easier for, you know, it's like, okay, now I'll make a video on that
Mm-hmm.
and that.
On the 26 hours survey.
Let's see.
Good night.
Yeah, you too.
Let me get the wrong thing.
Let me change my table to yours. So what was your end?
That's 26, right?
I don't know, I'm asking you.
I don't know either.
It says of this number of tires sampled.
26.
Okay.
I think that, okay, that's why I put in the wrong one. I put 30, because that would be yours.
Okay.
Yeah, that makes-
See, I was just gonna run through it, not see, that's the one thing I didn't check was to see what you put in.
Yeah, because this one, right, this is the end. Of the 26 tires surveyed.
Yes.
Oh, right.
Hey, you know this next problem for the 7, is that my number says 19. Oh yeah, there should be the same 19. Okay, so a survey of 35 smokers of this generation was done to see if the mean starting age is
a piece of paper.
at least 19. I would write that as the sample mean.
Okay, so the generation, okay,
'Cause I don't
from
have a regular
generation to generation, the mean age of smokers first start to smoke value varies. However, the standard deviation, whoa,
Sorry, I tried to blow it up a little bit.
standard deviation of that age remains about constant. So that's talking about the standard deviation of the population,
Okay, so I got that. Population standard
Which
deviation,
is-
2.1.
okay, 2.1.
Count.
Okay, so then we get a sample mean,
Sample mean? What is?
so it says,
Okay, right.
so it says, a survey of 35 smokers of this generation says that the mean age was,
At least 19.
no, it says
Huh?
the sample mean was,
Oh, 18.2.
so the sample
starting
mean was
at the
18.2,
Oh.
and the sample standard deviation was what?
The sample 2.1. Oh, sample right here, 1.3.
1.3.
Okay, so what was the 19 for?
And then the N was, scroll up. So
35.
the N is 35. So now what they're saying is,
Something like
okay.
At least the age of 19.
Yeah.
Does it have anything
so
to do
my
with
null, my null hypothesis
Mhm.
is that my mean is equal to
That's it.
19.
So equal to or equal and greater, right? Because this one says equal or greater.
Yeah, see, this is where I always come in.
Yeah.
Equal to or if it says at least, it can be
Okay.
equal to or greater than. Okay. Which means that my mu now is less than 19.
And this is that there's a 5% level, so I know my alpha is 5.
And my alpha is 0.05.
Right.
Okay. So now,
Another row. Sorry. I'm pressing circle.
okay. So there's my N, there's my population standard deviation. My HO is greater than, my HA is that, okay. My X bar was 18.2, my sample standard deviation 1.3, my alpha 0.05. So don't need this twice.
Yeah.
So we already have that. So now, this is not a proportion, so I don't have P
Okay.
prime. Yeah,
Okay, because it has the mean.
right.
Okay. Wait, can I just put myself a note?
Okay. I'm either doing proportions or I'm doing means.
Right. Okay.
Okay.
Where's that? Oh, text box, that's why. Okay. Is not portion, so I
Well, see, what does P
Right, and for
P
proportion,
prime?
which makes sense.
P prime is what?
I just want to remind myself.
is the
Proportion of
proportion,
a population.
no,
What?
close.
Oh, no, proportion of the sample. The P is proportion of the population.
See, now you're starting to understand why in the beginning of the
I'm getting
semester, I am so,
I
you
feel
got to
bad.
have the symbolism down.
Yeah,
Because I'm always talking about statistics and parameters.
right.
Mom, done with the phone?
Oh, yes.